Hey folks, this is Mobile AppSec 101. I'm Tony Ramirez, and this is a course on mobile application security testing. Today is our last video, video 5 of the Mobile AppSec 101 series, and we're covering everyone's favorite topic, tools for testing. So we have a couple learning objectives today. We're going to talk about common tools that you might be using for doing mobile application security testing. But not only that, we're going to talk about some methodologies behind that testing when you first start using those tools and what you really should be doing. We're going to cover network, forensics, and code quality. And really, this is really just the start of getting into the testing and kind of using these tools and kind of figuring out which tools you like the most, because that is an important part of security testing. So let's actually get into our tools of the trade. For a lot of us, we know what tools we like to use. So what I will recommend is if you have a preferred terminal, a preferred network interception tool, or other tools that you know you can rely on because you've known them for a long time, use them. You should use what you're comfortable with. But there are some tools in mobile that are really mobile specific, and if you've never encountered them, it's likely you haven't heard their names, and it's really important to kind of dig in and learn those tools because they are widely accepted by the industry and they're super useful. So, figuring out what those are is important. And really, having rooted and jailbroken devices, as we said before, are crucial to doing this testing. Having developer tools is really important too. That could be things like using Android Debug Bridge or using part of Xcode to install apps on your iOS device. Really, these tools are super crucial to perform a lot of these testing. And I will say this, you're not going to be able to install an app without them, and that's the first step to testing. Not only that, but there's a lot of crucial reverse engineering tools. I kind of mentioned this earlier, but there are tools that are specific to mobile. Frida and Radare are really useful for mobile. They aren't specific, but they are so widely adopted for mobile application security testing that I almost always recommend them to anyone who's doing any mobile security testing. And finally, the one thing that's really important across all of security is having that patience and creativity and just having that attention to detail. Because a lot of what you're going to be doing when you're testing apps isn't really a formula. It's kind of looking at things, looking back, seeing if that changes, seeing if small things come up later, and how they're affected across this whole testing thing. So remember that. There is no right order. Let's start off by talking a little bit about network interactions. We're talking about man-in-the-middling your device, seeing those network calls, seeing what's being sent and received and how they're being sent and received. We want to test before and after login because some applications will implement security protections or certificate validation hosting verification on the application, but they won't do it on certain requests after login. So it's important for us to kind of get that full coverage, make sure that we're able to see what happens after login, see if those protections are in place. But not only that, we also want to exercise the app. I said this in the previous video, but exercising the app is so incredibly important when doing security testing. It's a crucial task because really we want to see how all those flows interact, how certain endpoints happen, and how certain interactions happen, and really it adds more data to what you're collecting. And if you miss something and because you didn't exercise the app in a certain way, you're going to miss out on some security issues, and they could be a big issue down the line. We're also looking for sensitive data. We're also looking to bypass a lot of these controls and see what actually is being sent by the app, because it's really going to help us do web API testing when we get further down the line. And for those of you who are already web security experts, it's likely that you've come into mobile and the first thing you've done is tried to intercept traffic and right away realized you can't. A lot of the time that could be because you're not able to intercept that traffic because of pinning. And getting past those controls is super important because that's really the first step to doing a lot of that type of testing. So one thing I find that's really helpful for people who are first doing network testing in mobile is kind of understanding the architecture of what you're actually setting up and how you're doing that. And for me, it helps to kind of see that. The network logic here is basically we're intercepting traffic via a proxy. In this case, we're showing Minim proxy. We have a CA cert installed on the trustor of that device, and now we're intercepting those calls between the server. We want to see what's being sent. We want to see how it's being sent. Maybe it's being sent over port 80, otherwise known as HTTP. Hopefully it's being sent over 443, and maybe it's using some controls to kind of protect itself from being man in the middle. Those are important to keep in mind because down the line, as I said before, we're going to want to bypass those. The next common attack surface area we're going to talk about is data at rest, or forensics testing. We're testing the data that's being stored on that device, and we want to see how it's being stored, where it's being stored, and not only that, but if proper procedures are being used to store that data. So the one thing I will recommend to you is that you kind of are doing testing. You probably have a login, you have a password. You want to look for those terms stored on the device. But you actually don't want to just look for those terms. You want to look for variations on those terms. I kind of like to say, like, take a rainbow table approach. Consider your username, consider your password. They're likely not going to only be stored in plain text across an app. They might be stored in base64, they might be hashed, they might be encrypted, but we really want to find it when it's in that reversible format. So kind of creating ways to look at that data in different ways is really helpful because, you know, if we're storing a password in base64, that's a reversible format, and that's a big no-no. The other thing I'll say is get really comfortable with terminal tools because you'll want to grep for these terms, and it'll make your life so much easier if you get good at using those tools. The other end of that is the jailbroken and rooted device thing. We talked about it before, but really, if we want full access to that device and, you know, being able to see certain locations on iOS and Android are really only possible through jailbroken and rooted devices. They really do make security testing easier. So there are some locations on your device that can be viewed without jailbroken and rooted devices, and one of the most common that comes to mind is the SD card on Android. iOS doesn't have an SD card, but Android does. And the SD card actually isn't a physical SD card. What it actually is it's a convention that stayed from old Android. When devices started getting, you know, kind of old and they wanted to expand storage and, you know, maybe there wasn't enough storage for apps on those devices, they had to come up with a mechanism that allowed people to expand their storage. So what did Android do? They created the SD card. That convention stayed, and now it's called emulated storage, or external storage, or just public storage. There's a bunch of names for it. Just be aware if somebody's talking to you and they're like, oh, you're storing that in emulated storage. That's not good. They're referring to the SD card. But here's the thing. Apps can write there. They can store sensitive data there. Users can access it. And other apps can read the data that's been written by users and other apps there. It's a really insecure location to write sensitive data. So if you're writing something like runtime variables or, you know, sensitive values, you know, that's a big no-no, and you want to make sure you're not doing that. Again, this is an Android specific thing, but it's something that can be accessed without a rooted device. Another example would be backup and system logs on Android and iOS. So, you know, storing that type of data there is not a good thing. But on top of that, you know, we're also interested in things like hardware backed storage, like KeyStore and Keychain, which again are only accessible through jailbroken and rooted devices, but we really want to understand the logic of how that app works. Maybe there's a JWT stored there, maybe username and password, maybe something else. And really, the only way we're really going to understand the app is using that information. We really want to get as much context as possible. And that kind of leads to the next point. I'm going to repeat myself again. Exercise the app. If you don't exercise the app, you know, you're not going to get the full picture. This is not meant to be an exercise infomercial. I am not Richard Simmons, but you want to exercise the app. So the final section we're going to cover now is testing code quality. And this is actually kind of a broad topic because it does include reverse engineering the app, but it also kind of includes understanding the code configurations that your app could have and making sure that you're using secure best practices, making sure that you're using, you know, the free security tools that can harden your app like ASLR, or, you know, disabling debugging within your application and making sure that there's no, you know, extraneous code that really isn't necessary. And at NowSecure, we take this black box approach, and a lot of people do that too, because really we want to take this attacker's point of view, because what an attacker is going to do is they're going to pull your app off the App Store, they're going to decompile it, they're going to disassemble it depending on the type of app it is, they're going to use common tools to do some analysis, they're really going to want to understand how that app runs. So using developer tools, using tools like Frida and Radare to actually, you know, reverse engineer your app is really common. Now, there's more to this than I'm leading on. It's a difficult skill and it takes experience. It's something that you learn, hey, this is something I've seen before. I'm going to look back on my notes from previous assessments and see, hey, you know what? I saw this happen and the developer did this. Let me go back and look at this app and see if they're doing the same thing. And maybe, 4 times out of 5 that might be true. That fifth time it might be not true, and over time that might decrease because, developers get better at writing apps. That's the truth. But let's talk a little bit about what that actually looks like. So in the case of Android, we are, decompiling an app. Android apps are DEX code, and there's a couple things we can do to reverse engineer it. If you look at the DEX code, it looks pretty ugly. It's something that's not really decipherable, but we can go to Smalley code or even jar code because remember, Android apps are just Java or Kotlin, and basically they're running in a Java machine on your device. It's called the Android runtime now, but it used to be just a Java machine. So what we can do is go to the Smalley code, which is less lossy, and we're able to actually see what that Java machine code looks like. If we go a little further back, we end up at jar code, easier to decipher, but it's a little bit more lossy. On the iOS side, it's a little more complicated. We're dealing with executable files that need to be disassembled. So we end up with this executable code that looks kind of like a blob, and we end up with disassembled code, which is just assembly. We are doing the same type of testing, looking at that code and trying to decipher it, and using our experience to determine what that app might do. But the first time you do this, you're going to look at it and wonder, oh, is this assembly? And the answer is yeah, it's assembly. So the last thing I want to leave you with is a checklist. You're coming to this point now where you've likely gone through these videos, you've listened, and now you're kind of thinking, well, now I have to go out into the real world and test mobile apps, or now I have to create a policy, and now I have to actually implement everything I watched. So my tip to you is to start off real simple. Think about these MASVS docs, this MSTG doc, because they really are useful depending on what you're doing. The other thing is, get a jailbroken and rooted device. They are really helpful. They are going to allow you to use the testing tools that everyone in the industry uses, and that is a huge tip I will give you. And finally, keep in mind that don't trust the app, don't trust the device, don't trust the user, don't even trust the other apps that the user might have on their device. Those are things you have to keep in mind when you're securing these apps and considering what threat model they might fall into. So let's take a quick moment to summarize this video. We went through the pen testing processes, we talked a little bit about the tools you should be using, and finally we came up with some methodologies on how to use those tools and how you should be doing things. Remember to exercise the app.